system is introduced and how the analysis is to be carried out for two different configurations, that is the star connected arrangement and the delta connected arrangement be carried out will be discussed. Now three phase system, you can say it is consisting of three single phase system which are time displaced by 120 degree. So here say it is having a representation of one voltage VR, another voltage Vy, third voltage is Vb. So what we can see that this particular Vy is lagging by 120 degree to the VR voltage, where say Vb is still lagging by 120 degree to the Vy. So this particular is coming out to the three phase system. This particular is resulted because say the practical generators which are of say moderate and the large capacity, they are of three phase arrangements. So how this particular three phase is made? Three identical windings are placed inside the generator. So one is having a red with the red color, red, another is with the yellow, and third one is the blue. So these particular are 120 degree electrically displaced. So from this point onward, you can see that when say they are 120 degree displaced and they are rotated in the uniform magnetic field, so the generated voltage will also be 120 degree displaced likewise. So that is, you can say, how the three voltages are coming out to be there. Now this particular has already been highlighted that it is because of the identical windings. So the generated voltage will also be having the same magnitude likewise. If suppose you wish to express them into an instantaneous basis, so one particular is taken as a reference. Let's say I am considering Vm sine of omega t. So this nomenclature is well understood with the single phase analysis. Correspondingly Vy, which is lagging by 120 degree, so it is right this. Vb is lagging to Vy by 120 degree, so it will be minus 240 degree. This particular can also be written as Vm sine of omega t plus 120 degree likewise. So this particular we will be following. Now we have to understand what are the advantages of three phase system and why we are going for this. So when say we have to generate and transfer the same amount of power, then the amount of conducting material required is much less as compared to the three single phase system. Now three phase machines are smaller in size in comparison to the single phase machine of the same rating. Now one important point here that the three phase motors are self starting as they can produce the rotating magnetic field. However, if you are making a comparison, then the single phase motors are fundamentally not self starting, or you can say non self starting type, because they produce only the pulsating magnetic field. So pulsating means the magnitude is changing at only a point where say in the this particular the magnitude is appearing as peak value at different, you can say, location in around the circumference. So that is giving rise to the rotating magnetic field. Now in the voltage regulation, which is another aspect, is better in the three phase system and so on. So these are, you can say, the typical advantages because of which the three phase system is used for all practical considerations except, let's say, for the residential household where we are having say the power consumption of very low rating likewise. Now the advantage of this three phase arrangement, that for the domestic we can tape the single phase from that, and for the industrial they can use the three phase power. So likewise, so three phase transmission system is having the capability to support both the three phase load and the single phase load. So this particular is giving rise to the nature of the two systems. One is the star connected, another one is the delta connected likewise. So three phase generators, they are always in they are connected in the star arrangement. So star means here say the star formation. Because of this structure, this is also regarded as WYE, Y connection and so on. But that particular Y or delta, that is decided by the load. The generators are always generating the voltage while say the windings are connected in star arrangement. Likewise, so the same nomenclature VR, that is having a 0 voltage reference, that is taken as a reference. Vy is 120 degree lagging. Vbe is coming out to be 120 degree leading from the VR, or you can say lagging by another 120 degree with respect to Vy. So that is how we are able to have, and this particular is regarded as the positive reference, or you can say the R by V is the positive sequence basically, but there is say the negative sequence is also there, but that is not a part of our discussion. So now every phase has the two terminals. Likewise, one is the start and finish. So basically when we are having say the three phase under consideration, so we will be having the 6 such terminals. So these three phases are formed by having say the interconnection of these 6 terminals. So that is giving rise to the star or the Y connection, which we have discussed, or we can say referred in the beginning, and the delta or mesh connection. So this is how say the star connection is formed. Let's say the R phase which we discussed, that is having the winding R dash. Similarly, Y phase is having Y dash terminals. B is having the terminals B dash. So the polarity, because of the dot convention etc., is such that this particular R dash, Y dash, B dash, they are coming out to be of similar nature. So they are connected, and that's particular they carries the name star. So you can say star means S stands for star connection. You can also say that the similar terminals are joined, and that is forming a new terminal which is regarded as the neutral. So this particular, either the dash terminals can be formed to have a neutral, or the undashed terminal, so that is R by B, can be combined to form the neutral, so performance will be the same. Likewise, so we will be referring in the other text that R dash, Y dash, B dash terminals are joined to form the neutral connection. The delta carries where say the dissimilar polarity terminals are connected. So in this, the cyclic manner arrangement is worked out. So R is getting connected to the Y dash, Y is getting connected to the B dash, and similarly B is getting connected to the R dash. Likewise, so that particular is giving a formulation like mesh. Now here say we have to discuss or deal with the concept of line and phase voltage as well as the line and phase currents. So as mentioned that the three are, let's say they are generating the voltage in, or you can say it is a star connected arrangement. So with respect to the neutral, the corresponding voltage to the terminal will be regarded as the phase voltage. So that is VRN. Similarly, you can have the VYN, VBN likewise. Whereas say the voltage between the two terminals, which we are saying the lines, that is regarded as the line voltage. So that will be VYB. If you are further elaborating, then you can easily find out the VYE is equal to VYN minus VBN. Likewise, so that we will be taking up. Now, as say one particular voltage is to be demonstrated. So here say that it is having a three voltages VR. This particular is Vy. This is Vb. So the three voltages are there. This particular is also representing the line currents, but for the time being you please keep them aside, or you can say simply consider that the respective phase current is maintaining the same power factor angle theta, or that is decided by the impedance angle. So the way we suggested that VRY is to be calculated. So this VRY is nothing but VRN minus VYN, or how you will be spelling out VRY, potential of R with respect to Y. So that is a valid assumption. In this, it is attempted by the law of this particular is a subtraction. So the subtraction is attempted as an addition of the negative phasor. So you have drawn the negative phasor. So this is Vy and this is the negative phasor you have drawn, and these two are added by the law of parallelogram. So that particular is giving rise to the value that Vry is root 3 times Vb and having a 30-degree angle. So Vr was our consideration. Here say we are spelling out Vry. So you can make the consideration that the voltage magnitude Vry is root 3 times the phase voltage Vp. This also leads by the 30-degree to the Vr. So you please be mindful that these two identity or sub-statements we are able to obtain from this. The magnitude can be calculated by the law of cosine, so that particular is well understood to you likewise. So this particular square plus this particular length square minus 2 of Vr Vy, this angle is 120 degree also. So these are the two takeaway for the star connection, that the line voltage is root 3 times the phase voltage and the line voltage leads by 30 degree to the respective phase voltage. So similarly we can calculate the voltages for others, or they will also be maintaining the 120 degree cyclic arrangement. So when say that particular cyclic arrangement is made, so Vry is listed out like this. V by B, it will be lagging by 120 degree. VBR, that particular will be further lagging by 120 degree to the V by B likewise. And in the star connection, the phase current will be equal to the line current. So that's why they are left unchanged. Now this we have already covered, or you can say summarized, that the line voltage magnitude is root 3 times the phase voltage that we have gone through. The line voltage leads by 30 degree to the respective phase voltage. The line and phase currents are same for the star connection likewise. Now this is the another popular configuration, which is the delta arrangement, and you will come to know that practically when say we are saying the 3-phase machines of moderate to high ratings, they are normally bound in the delta arrangement. So this is R dash is a nomenclature, Y dash is a nomenclature, B dash is a nomenclature to represent the respective phases. The phase currents are given a variable name I1, I2, I3 in this, where say the line current drawn, that particular will be IR, I by IB. So IR is nothing but I1 minus I3. So by the law of KCL you can establish. Similarly IY will be I2 minus I1. Similarly you can calculate the IB. Now here whatever say the voltage is appearing, that is a line voltage, and this particular line voltage is also the phase voltage. So that particular is the beauty. Here say we will be repeating the same process for the current calculation, the way we have calculated the line voltage for the star arrangement. So in calculating, so these are, you can say, the I1, I2, I3, these are the phase currents we have marked. Now how the IR was spelled out, that was the I1 minus I3. So to attempt that minus I3, you are drawing a opposite phasor, attempting it by the law of parallelogram. So the IR is evaluated as root 3 times the value of phase current, that is I1 in this case, or you can say IP, because I1, I2, I3 they will be of equal magnitude for the balance system, so that is the IP. Now another important point, that this IR is lagging by the I1 by 30 degree. So the two takeaway from this is that the line current is root 3 times the phase current. Line current lags the respective phase currents by 30 degree. Now as a summary you can put forward that whatever say we have given, when say we are giving a parameter of a AC system, unless it is specified, it is the line voltage we are specifying likewise. So the relation of the line voltage to the phase voltage, so line voltage is root 3 times the phase voltage in the star, line current is to the phase current in the star, line voltage lead the phase voltage by 30 degree. So similarly for the delta connection likewise. How the systematic procedure is, we have to first identify the connection, or let's say it is specified in the problem, so that is okay. From the given AC system data, calculate the phase voltage. So usually the line voltage is specified, but from that we will be calculating the phase voltage. So this phase voltage is to be calculated keeping the configuration in mind. So for say star connection it will be VL upon root 3. For the delta connection it will be the same line voltage likewise. So that particular is giving us the magnitude, and we will be taking as a reference, so that will be Vp0. From this we will be calculating the I phase current. So that is simply the reference phase voltage divided by the impedance of the phase. Thereafter we will be able to calculate the line current using Ip, the reference information. So IL is equal to Ip in star connection, IL is equal to root 3 times Ip in delta connection likewise, and thereafter we will be able to draw the phasors and assign the appropriate angles. So assign the appropriate angles means, here say the calculation is for the magnitude, angle means the line current lags the phase current by 30 degree in case of delta. So that consideration we have to keep in mind. Similarly, the line voltage leads the phase voltage by 30 degree in star connection. So let us take one example. Here say the three impedances, each of tan angle 45, are connected to the 400 volt. So this 400 volt is the line voltage. Now we have to calculate the line and phase currents and the voltages when impedances are connected in star or delta. So 400 volt is given. For the star connection, the phase voltage will be line voltage divided by root 3. Then we will be going for the phase current calculation. So the phase current is the phase voltage divided by the impedance. So impedance is given as tan angle 45. So you will be able to calculate the IP likewise. Now this particular is the current for the R phase. So that is written as it is, the way IP is calculated. Thereafter IY, which is lagging by 120 degree to this, so that is 23 angle minus 165. Minus 165 comes out from minus 45 minus 120 value. Similarly IB is calculated, so it is lagging by 120 degree to the IY, so that particular is attempted like. The phase voltages will be Vp with a reference 0 degree. So once say the R is given, by voltage will be of same magnitude but lags by 120 degree. Similarly the Vb will be same magnitude, further lagging by 120 degree, so 240 degree. On the line voltage, this particular is the relation. Just to demonstrate it, we can calculate it like this. They are the phasor quantities. However, you can simply write it that the value is root 3 times 230, so that will be resulting into 400. This particular is leading by 30 degree to the respective phase voltage, so 0 instead of 0 you will be having 30 degree. Now others, they will be simply lagging by 120 degree but having the equal magnitude, so you have written these line voltage. For the delta connection, whatever say the line voltage, that particular will be the phase voltage. So the phase current is the phase voltage divided by the impedance. So here say the current magnitude is increasing. Now I1 is calculated. So that is again say we are taking the phase current as a reference. So 40 minus 45. I2 will be giving you magnitude as 40, but this is displaced by 120 degree or lag by 120 degree, so minus 165 degree. Similarly, I3 you can calculate. The line current is having a property that the magnitude is root 3 times the phase current, so 40 multiplied by root 3, but this is lagging by 30 degree to the phase current. So here say the phase current is having angle 45 degree. This is further lag by 30 degree, so that is resulting into minus 75. Iy, it is of the same magnitude 40 root 3, but angle will be for lagging by 120 degree to the IR, so that particular will be minus 195. On this way you will be able to calculate. Line and phase voltages are same for the delta connection, so they are written simply the 400 is taken as a reference, 0 degree, minus 120, minus 240, likewise you can assign. Now in this what we have gone through, the advantages of three-phase system over the single phase, they have been highlighted. Relation of the line and the phase quantities for both star and the delta connection has been highlighted. It is requested that the solution be carried out using the per phase analysis basis. So this per phase is basically, you can extend it for the three phase simply while having say the per phase quantities in mind, whether it is a star connection or the delta connection. So power factor is the cosine of the angle between phase voltage and phase current. So it is precisely the angle between the phase voltage and the respective phase currents. So don't get confused that it is related with the line voltage and line current likewise. The line voltage VL is equal to root 3 times Vp and leads the respective phase voltage V. The line voltage is VL is equal to root 3 times Vp. It leads the respective phase voltage by 30 degree in the star arrangement. So that particular is highlighted. Similarly, the line current is root 3 times the respective phase currents and it lags the respective phase current by 30 degree in the delta arrangement. So next we will be going for the three phase power measurement while having say the different techniques. For further reading you can refer these two textbooks.